All right, lesson 2-2. Before we start on 2-2, let's review what we've learned in the past. So the first one, number 1, deals with inverses. And so if we dealt with inverses here, let's see what I got. If we dealt with inverses, blank page, what is the trick to finding an inverse? Question for the classroom. How do I find an inverse? That's what this means right here.
Switch X with Y.
Yeah, I'm here on Zoom, switch X and Y, and I'm here in the classroom, substitute the X's. So we switch the X and Y. So remember, the f of X is the same thing as Y equals. So to solve this, we can type in X equals 2Y minus 5 over 3Y plus 4. And as a reminder to those who have not taken the test, you can graph this and already know what the solution should be. You can graph that right there on Desmos, and it will show you what the answer is supposed to look like. Okay, so just keep that in mind. To solve this, I'm going to actually do the algebra here. So to solve, how do you get rid of division? What's the opposite of division here? Multiply.
Multiplication.
So multiply by 3y plus 4. All right. So the other Zoomers start to participate as well, not just Ali. Don't leave it on him. Classroom, thank you. 3y times x. I'm going to distribute this over here on the left side. When I distribute here, 3y times x, I'm going to actually write out the order. I'm going to write that as 3xy. And then I have a 4 times x, which is going to be 4x. All that will equal 2y minus 5. And here's the step that a lot of students struggle with if they're doing algebra here. The way you solve when you have 2 y's, you notice how I have 2 y's here? The way to solve when you have 2 y's is you get the y's on one side of the equation, and you get anything that doesn't have y on the other side.
No.
So what I'm going to do is I'm going to move this positive 4x to the right side. How do you move a positive 4x over? You subtract 4x. So I will subtract 4x from both sides. And now how do I get this positive 2y to the other side? I'm going to subtract that as well. And so now I'll have my y's on the same side of the equation. So I have a 3xy minus 2y. By the way, these are not like terms. They don't share an x. They're going to stay separate. So 3xy minus 2y is going to equal, and over here I have a negative 4x minus 5. Now we're getting close to the end. Now that your y's are on the same side of the equation, you can do a greatest common factor, a GCF. So the very first lesson of the school year, the very first bellringer, we talked about GCF. That's where you pull out things that are shared. What do both of these terms now share on the left side of the equation? Y. So you can pull it out. It's like the opposite of distribution. So if I pull that out, I'm left with a 3x minus a 2. And all this will equal a negative 4x minus 5. Which brings us to our last step here. How do you get y by itself? How do I get rid of this multiplication of 3x minus 2? What's the opposite of multiplication? 5. So I can divide it out. And so we come up with our inverse. So the symbol for inverse is f negative 1. So I say f negative 1 equals negative 4x minus 5 over 3x minus 2. That's what we're going to say the answer is. And I'm going to show you something about the domain, just to show you what this means in a second. The domain, you're never allowed to divide by 0. So on the opposite, on the bottom, anything doing with the x always lies. Remember that rule that inside lies, outside tells the truth? Well, the inside is talking about the x, so it will lie. So the domain here, what the x will not equal, it's going to be lies. Instead of a negative 2, it will be a positive 2. And instead of a multiplying by 3, it's going to be a division by 3. How I got that, the reason mathematically that works out, If you're supposed to set it equal to 0. And honestly, for domain, you're not allowed to divide by 0, so I should say not equal to 0. You can solve this. How do you get rid of a -2? Add 2. And so you have 3x cannot equal 2. And then how do you get rid of the multiplication of 3? You divide by it. So that's where you get the 2/3 from. Now, I don't expect you to know all the algebra. You could get this from the graph. So I'm going to circle this part of the domain because that's kind of a key portion of this answer. And now we will graph what I told you we're going to graph at the very start, what I wrote down in red right here. We're going to graph that and see if our answer choice matches it. So I want to pull up Desmos, and we'll graph those functions. So the first one was that x equals, and can y'all read off, I think y'all have this written down, 2y minus 5 over 3x, or 3y plus 4? Okay, so that's what I said. Without doing any work other than switching x and y, we said we can know what the answer is going to look like. It's going to look like the picture of this graph. Now I want you to notice something. This graph breaks. There's a break in here when at x equals 3/2. I can't say does not equal, so I'll just put x equals, not 3/2. It was 2/3, wasn't it? 2/3. Notice, you see how that breaks this equation perfectly? See how it divides it? That's what it's talking about. That was the break in the domain that we had. Okay, now what was our answer that we came up with? We came up with that y equaled negative 3x. Was it not negative 3x? Ooh, I really thought it was. Oh, you're right. I stand corrected. Negative 4x, okay? Minus 5 over 3x minus 4? Minus 2. And did we get the same answer? Yeah, so we did it correctly. So that was number 1. Let's take a look at number 2. On number 2, oh, I didn't realize what number 2 said. Number 2 says, find the domain for both the original and the inverse. So we already found the domain of the inverse. So for f-1, we already found the domain is that x cannot equal that 3/2. That's where it divided it. And I'm not going to look for range here. What I will do, though, is I'm going to graph f, and I'm going to do a little trick. What's up? Oh, 2/3. Thank you. Thanks for correcting me. Okay, so this is the inverse. Here's what I'm going to tell you right now. What's the difference between the inverse and the original function? What did we switch?
You switch x and y.
We switched x and y. Well, another name for x is domain. And another name for y is range, which means this answer will be over here, the range. Because we just switch x and y when you transfer between a function and its inverse. So we know the domain here. Knowing the domain of the inverse means we know the range of the original. So I'm going to graph the original, 2x minus 5 over 3x plus 4. Y equals 2x minus 5 over, that's not how it's supposed to look. Let me try it again. I can't remember if that's it or not. Let me check. 2x minus 5 over 3x plus 4. 3x plus 4. And so here's the original problem. And so what that means is whatever value of x it divides here, it's going to be the range on this one. Now we can look at the denominator and find out it's going to be negative 4 over 3. Now I'm just going to write it down and then I'll explain why it is as it is. For this problem right up here, we would solve that 3x plus 4 cannot equal 0 because you're not allowed to divide by 0. And we would solve this. And so how would you get rid of the plus 4? So 3x would not be able to equal minus 4. And then how do you get rid of the division of 3?
Times by 3.
We divide it by 3. Dividing cancels the multiplication. So over here, the original one's x cannot equal negative 4/3. So that means this one's, the inverse's range is that y will not equal negative 4/3. Now, let me go back to the graph and try to explain this without having so many lines on the screen. Let me take this off so we just have here. What we just found is that y would not equal. Now, Desmos does not have a not equal, so I'm just going to put equals negative 4 divided by
3. What do you notice about this black line? Do you see how it separates these two green pieces by way of range? It separates the range values, the y values. This piece is below it, this piece is above it. So that's the point that the y never equals. It never equals this black line, it never equals this blue line, which the blue was 2/3. So we did do that correctly. Now, for a lot of students, this is probably a little confusing, and that's okay. Honestly, I've been prepping you because I know how hard this is. This is actually lesson 2.5. We haven't gotten to lesson 2.5 yet. So I've been prepping you on all this so that when we get to 2.5, it's not just, hey, here it is in one day, now you go master it. I've been showing you this since chapter 1. Okay, so I've been giving this to you in advance for a reason. There's a point to Mr. Voorhees' madness, and that's what it is. It's just to help prepare you to see it over and over and over. In summary, what's the rule with division that you need to remember? Yeah, when you see division, what are you not allowed to divide by? 0. And that's how I was solving these domain ranges. I was saying it can't equal 0. That's how I did both of them. With square roots, what's the rules of square root? What are you not allowed to have with on a square root? A negative square root, that's correct. You're not allowed to have a negative square root. Perfect. All right, and we got one more problem. Thought I copied this, so here it is. Okay, number 3 now. It says solve this problem. All right. Let me hear you walk through the steps. By the way, we could use calculator mode. Remember calculator mode? It's been a little while since Tuesday. Calculator mode's like this. You divide the equation at the equal sign. You list the left side as y1. You list the, minus 6. You list the right side as y2. And you look where the graphs intersect. Okay, so let's go get an answer by calculator, and then we'll do the algebra. So can I clear off these pictures? I'm going to do it either way. The equations were y1 equals, yeah, that's right, the third root. You have to go to functions, and it's miscellaneous where that is, right there. Third root of, what did you say? X plus 3 with the minus 6 on the outside. Okay, and y2 was minus 5. Why is it not graphing? Oh, there we go. Make it y. All right, and the answer is going to be where these graphs intersect, the x value. We're solving for x. So what's the x value at the intersection? -2. So the answer, according to graphing, is -2. Notice on the problem, was there a y in this problem up here? That's why you solved for x. We added the y's. We got x equals -2. And for this to work, I had to take off that y2. I just had to do y equals 4 for some reason. Let's check my off. Yeah, -2. Yeah, it's -2. Okay. And you only look at the x, because in the original problem, let me move this. You see how the original problem only had an x? So that's why we solved for x. I added the y just so Desmos would graph it. But you don't pay attention to the y, you look for the x. Okay, now let's solve this by hand. If you're going to solve this by hand, we got to get rid of the outside stuff first. So deny, how do you get rid of a -6? What's the opposite of -6? +6. So we're going to add 6 to both sides. Which means we have the third root of x plus 3 equals, I'm getting here, +1. Now, a third root is the opposite of a cube. If you haven't seen that before, what this means is that's the opposite of a cube. So to cancel a third root, we cube both sides. We do a third power. Now, that will cancel the third root with the third power. So you're left with x plus 3. On this side, what is 1 times 1 times 1? Still
1.
Nice, still 1. So finally, how do you get rid of a +3?
-3.
-3. So our answer would be that x equals -2. Is that what it's supposed to be? Now, which way is easier? Graphing. Yeah, if you're doing a multiple choice test, just use the graphing if you want. But if you have to show your work, there it is. Now I'm doing one more that's a lot harder, just so you can see this one more time. Which way do you want me to solve first? Do you want me to solve by algebra first or graphing first? In the classroom, I'm hearing algebra first. Okay, so this time I have two x's. And so the trick here is to try to get rid of the square root. Go for it. You can take off the peeling if you want on those dividers. All that peels off if you want to do that. Yeah, go for it. Got a pencil sharpener, so let me pause my recording. All right, so let's take a look at this problem. Whenever you're dealing with this root, that's going to be the trick to get rid of. So I'm going to actually I know this x looks like it's by itself. I'm going to start solving for this x. And I'll show you what's going to happen. So first, I'm going to get rid of the plus 4. How do you get rid of a plus 4? Minus 4. Now, a lot of this is just tricks along the way of knowing, hey, if I got to solve for x, I got to do something about having multiple x's. And so I'm trying to get this x outside of the root. That's the idea. So I have x minus 4 equals the square root of 2x minus 5. Now, on the previous problem, we canceled the third root with a cube. What cancels a square root? A square, a 2. Now, if you square one thing, you have to square the entire side. So really, I'm squaring the entire square root, which means that goes away. And I'm squaring this entire side. Now, as a reminder, what does a square even mean? It means you multiply this by itself. So x minus 4 is going to get multiplied times x minus 4. And to do that, the technique we use is called FOIL. So to expand this right, to fully multiply it, I want to show it to you this way, where you can see x minus 4 written twice. That's what a square means, just right? Multiply it times itself. So what is x times x here? X
2x.
squared. Yep, and I got to distribute the whole thing. So now x is going to multiply times negative 4, which is
Negative
minus
4x.
minus 4x. And by the way, that was steps F and O. The F stands for first times first in the parentheses. O stands for the outside times the outside. What do you think the I stands for? Inside times the inside.
Inside.
Another negative 4 set x. And now the L stands for the last times the last. Negative 4 times negative 4. Two negatives make a positive.
Positive.
And 4 times 4 equals 16. All right, to solve this a little quicker for the sake of time, notice I have some common terms here. I'm going to subtract the 2x. And I want you to note it's going to combine with all of this. And I'm going to subtract 2x there too. All three of those will combine. Also, how do you get rid of a minus 5? We're going to plus 5. And I'm going to show you how this problem is going to solve. Okay, so I'm kind of skipping some steps that I normally talk through. This isn't the normal lesson. I just don't want to take too much time. I don't get to teach the new lesson. 2x's go away. The 5's go away, which means I'm left with 0 on this side. Over here, I have x squared. Now, this is a minus 4x, another minus 4x, and a minus 2x. So I think in terms of money, when you combine your terms, very good. I owe someone $4. I owe someone else $4. I owe someone else $2. I owe 4, 4, and 2. I owe a total of 10 x's plus 21. So the reason I solved it like this is anytime you have multiple x's, like I do here, the way we're going to solve this is with X method. Remember X method from the first day of the school year? So I got two problems today that we're reviewing the very first day of the school year. We learned about GCF, and we also learned about X method. X method, you take your A times C, which in this case is 1 times 21. What's 1 times 21? 21, that goes there.
21.
And we're going to look at putting B in the bottom, which is negative 10. You're going to find two factors, which we called M and N, that multiply to be 21, but add to be negative 10. And so just to help you out, the chart I use, in case you struggle up coming up with your numbers, is you write everything that can multiply to be that 21. So like 1 times 21 is 21. 2 doesn't go into it. 3 does. 7 times. And I don't think there's any other numbers. Okay, so we got our numbers. We're saying it's 3 and 7 can give me 10. How do I make it negative 10? So 7 minus 3 would actually be 4. So they actually, I'm hearing Pamela say both of them negative. Yeah, both of them negative. So we have negative 3 and negative 7. So to get our answers, next step is you split this power. So the power of 2 becomes a 1, so it becomes x minus that 3. And the other x, because you split the 2 powers became x and x now, minus 7. All this equals 0. So the only way to multiply and get 0, according to the zero product property of algebra 1 and algebra 2, is that one of these parentheses has to equal 0. It's the only way you can multiply and get 0. And so what value of x here would make this parentheses become 0? Positive 3 or negative 3? Positive 3.
Positive.
Positive 3.
Yeah, so really what you do is you set each one equal to 0. So x minus 3 equals 0. So you get that x equals positive 3. Or here, x minus 7 equals 0. And so we get that x equals positive 7. So we have 2 answers this time. 3 and 7. 3 and 7. Now here's what's frustrating sometimes when you solve with algebra. It's a term called extraneous answers. Let's go check out the graph. I'm going to now use graphing technique. So that took, would you agree this problem took a long time? I would say it did.
Yes.
I'm going to graph y1 equals x, y2 equals square root of 2x minus 5 plus 4. I'm going to graph these two and watch what happens. So we have y1 equals x. y2 is the square root 2x minus 5 plus 4. And lo and behold, how many answers does the calculator show you? It does? These graphs intersect each other twice or once? Only once. They only intersect at the x value of 7, which means 7 is a real answer. 3 is extraneous. It's not a good answer, which means all the algebra worked out right, but it doesn't actually work. If you plug it in, it doesn't actually work. So what am I trying to say? I'm saying use your graphing calculator first, because you could do all the algebra and still end up with an answer that's not right. We didn't do any algebra wrong. This doesn't work though. If you plug it in, what's 2 times 3? So we're saying 3 is x. I'll prove it to you. What's 2 times 3 here?
6.
6 minus 5 is 1.
1.
Square root of 1 is 1. So we have 1 plus 4. What's 1 plus 4? Does that equal 3? No, it doesn't, does it? What's happening is when we did the algebra, it's that square and the square root problem. At times, if you remember, if you're canceling a square, I said you need to have a square root with plus or minus. You need to have 2 answers. Well, with the square root, there's only 1, but when you solve it squaring it, it thinks there's now 2. And thus we have a problem with those. So all this to say, the best technique is to graph. If you graph, the graph will never give you the wrong answer, as long as you type it in correctly. Wow, was that an introduction? What are you learning about today? Lesson 2.2. 2.2, we are going to start talking about polynomial functions. So that's where we're going to begin now.